An intro to awesome engines. Jet engines are super important, you know. They help us fly very fast across the sky. They take us to faraway places all around the world. Think about big airplanes soaring high above the clouds, carrying people and goods. Without these powerful engines, our world would feel much smaller indeed. Travel would take so much longer and exploring distant lands would be a lot harder. These engines truly connect our planet in amazing ways. So what is a jet engine really? It looks pretty complicated from the outside, doesn't it? With all its metal parts and intricate design, but the main idea behind it is actually quite simple when you break it down. We're going to find out exactly how they work together. We will peek inside these powerful and amazing machines. It's like going on a science adventure to discover the secrets of flight. Prepare to be amazed by the engineering. Imagine you blow up a balloon really big, filling it with as much air as you can. Then instead of tying it, you just let it go. Whoosh! It zips and flies all around the room, doesn't it? A jet engine works a little bit like that energetic balloon, but on a much, much bigger and more controlled scale. It powerfully pushes a massive amount of air out the back, and this push moves the airplane forward. Understanding these engines is super cool. It really helps us see how science makes amazing things happen every single day. These engines are not just lumps of metal, they are brilliant ideas put into action. The result of years of study and experimentation. They show us how we can use basic scientific principles like physics and chemistry to achieve incredible feats like flying faster than sound. Let's get ready to learn about their awesome power. First up, when you look at a jet engine, at the very front is a big fan. You can often see its many long curved blades, especially when the engine is not running. This fan plays a crucial role. It sucks in a huge amount of air, like a giant mouth gulping air. Right behind this impressive fan sits the compressor. The compressor is made of many smaller spinning blades arranged in rows, and its job is to squeeze the air, making it denser. Next, this squeezed and now quite warm air moves into the combustion chamber. This is where the real fiery action happens. Think of it as the engine's furnace or a super hot continuous barbecue. Inside this chamber, fuel, which is a special type of kerosene for jets, is sprayed in a fine mist. This mist mixes with the hot squeezed air. Then a spark ignites it. This creates a controlled, continuous burn, releasing tremendous heat. After the intense heat of the combustion chamber, we find the turbine. The super hot, fast-moving gases produced by burning the fuel rush through the turbine section. The turbine looks like another set of fans or perhaps a series of very strong pinwheels. These incredibly hot gases, expanding rapidly, push against the turbine blades, making the turbine spin really, really fast. This spinning motion is very important for the engine to keep working. The turbine's main job, its primary purpose, is to power the compressor located at the front of the engine. How does it do this? Well, the turbine and the compressor are connected by a strong metal shaft that runs through the core of the engine. So, as the hot gases spin the turbine in turn spins the compressor. It's a very clever and efficient cycle. This ensures the engine can continuously suck in and compress air. Let's break down the whole process of how a jet engine works into 4 simple, memorable steps. It all starts with suck. The big fan at the front of the engine, which we talked about, vigorously pulls in enormous amounts of air from the atmosphere. Imagine a giant industrial vacuum cleaner, but many, many times more powerful and efficient. This continuous flow of air is the first essential ingredient the engine needs to operate and produce thrust. Then comes the next important step, squeeze. The air that was sucked in by the fan quickly goes into the compressor section. The compressor, as we learned, has many stages of spinning blades, each row squeezing the air a bit more. These blades push the air molecules closer together, compressing it into a much smaller space. This not only makes the air very dense, but also significantly increases its temperature, getting it ready for the next stage. Now for the really exciting part, the step we call bang. The hot, highly compressed air moves from the compressor into the combustion chamber. Here, fuel is continuously sprayed and thoroughly mixed with this very hot air. A special igniter, similar to a spark plug in a car but much more robust, lights the fuel-air mixture. It burns very rapidly and intensely, creating a powerful expansion of extremely hot gases. This is where the chemical energy in fuel becomes heat energy. And finally, the fourth step is blow. These super hot, rapidly expanding gases need to go somewhere, and they need to go fast. They rush with tremendous force towards the back of the engine. On their way out, they encounter the turbine blades, causing them to spin at high speed. Remember, the turbine is what drives the compressor at the front. Then the gases, still very hot and moving fast, blast out of the engine's nozzle at the very end. So how does all this incredible sucking, squeezing, banging and blowing actually make an enormous airplane fly through the air? It is all thanks to a very famous and fundamental rule in science, one you might have heard of. It is Newton's third law of motion. This important scientific law, discovered by Sir Isaac Newton, states that for every action there is an equal and opposite reaction. This principle is key. The jet engine, by performing its 4 steps, throws a huge amount of hot gas backward out of its nozzle at very, very high speed. This forceful expulsion of gas is the action part of Newton's law. The reaction part is that the engine, and therefore the whole airplane attached to it, gets pushed forward with great force. It's like if you were on a skateboard and threw a heavy bowling ball forward, you would roll backward. The engine does this continuously. All the different parts of the jet engine work together in perfect harmony, like a well-trained and perfectly synchronized team performing a complex routine. The fan pulls the air in, the compressor squeezes it nice and tight, increasing its pressure and temperature. The combustion chamber heats it up dramatically by burning fuel. The turbine cleverly uses some of that powerful gas energy to keep the compressor spinning, and the nozzle directs the final exhaust. So that is the basic secret behind the mighty roar you hear and the incredible power jet engines produce. Jet engines are truly amazing and sophisticated machines, a testament to human ingenuity. They use relatively simple ideas of air movement, fuel combustion, and the laws of physics. They combine these fundamental concepts with very clever and precise engineering. This creates the awesome propulsive force called thrust that lets us soar through the skies. Science,